Welcome to the Analog Astro Conference. Today I will be presenting my abstract, Breaking Boundaries, Redefining Crew Dynamics in Lunar Analog Confinement. I'm Sara Zafirovska, a molecular biology and genetics student at the Faculty of Natural Sciences and Mathematics at the University of St. Cyril and Methodius, Skopje, Macedonia. The lunar mission Kratos was conducted at the Analog Astronaut Training Center, AATC, Poland, from the 2nd to the 10th of August 2025. We had a 7-membered crew, where the members are listed in the presentation. Lunar analog astronaut missions are essential for preparing future explorers, especially younger generations, for the realities of living and working beyond Earth. They allow us to simulate isolation, limited resources, and operational changes, while training crews to think critically, adapt physiologically and psychologically, and function effectively and efficiently in confined environments. This mission focused on developing those exact skills, discipline, teamwork, and problem solving under pressure, which are key for the next generation of space professionals. The mission Kratos was unique and special because we intentionally introduced an overcapacity overcapacity scenario. 7 people in a habitat meant for 6. This tested interpersonal dynamics, space management, and operational discipline. Among the existing roles, commander, medical officer, biologist, data officer, engineer, and communication officer, we introduced a new role, habitat officer, that helped mediate living conditions and logistics within the confined module. There is an increase in social and spatial complexity, and we observed how different personalities and backgrounds influence communication and cohesion. The habitat included many habitat modules: waste disposal, toilet, geolab, clean lab, kitchen, passage or hallway, storage, sleeping quarters, and gym. In this habitat, we introduced a 7-membered crew, and this overcapacity setup led to multiple challenges, limited personal space, as well as higher noise levels. Psychologically, the crew faced irritability, fatigue, and reduced privacy, and physiologically, sleep and concentration were affected. To overcome this, we established a strict daily schedule and a rotational work plan. Each member was assisted to specific modules, for example, geolab, clean lab, kitchen, gym, and sleeping quarters, and rotating daily to balance workload and maintain fairness. This structured approach not only reduced stress but also strengthened teamwork, discipline, adaptability within the confined environment. Our original schedule was built for 6 members, so when we added a 7th astronaut, we had to redesign the workflow to maintain efficiency and mental well-being. We introduced shift-based task planning, ensuring not everyone worked in the same module at once, and extended the time slots for experiments and maintenance to avoid overcrowding. The lab use was staggered, creating a smoother rotation between stations, and to reduce fatigue and maintain focus, we also included short personal reflection periods, known as personal time blocks. We included a work-rest-leisure cycle adjusted to the reduced overlap. And these adjustments not only stabilized the daily rhythm, but also proved essential for sustaining productivity and mental balance in an overcapacity habitat. The mission included both general and individual experiments. Every group member participated in the general experiments, endurance, cognitive tests, psychological, physiological tests, bioimpedance, circadian rhythm, and others. And specific experiments were assigned based on expertise. The key studies focused on kombucha fermentation, spirulina cultivation, psychological and cognitive health, bioregenerative life support system, and time perception during blackout. During the mission, we introduced a 3-day blackout simulation. And during the 3-day blackout simulation, the crew faced complete darkness and minimal communication. The crew faced challenges such as overcrowding, limited visibility, and increased stress. Overcrowding added to the challenge, making coordination and movement more difficult. We conducted a protocol as a preparation for the blackout, and key tasks included organizing first aid kits, distributing flashlights, clearing pathways, and checking life support systems. Interestingly, we observed a positive social shift. Crew members became more socially engaged, emotionally open, and communicative with each other during the blackout. This exercise not only reinforced teamwork, situational awareness, and emergency preparedness, but also highlighted how shared challenges can strengthen both social bonds in a confined environment. The mission Kratos offered key insights into living and working in small habitat, especially under overcapacity or overcrowdedness simulation. We gained valuable psychological, physiological, aka biological data, demonstrated the feasibility of bioregenerative experiments, and confirmed the importance of structured schedules and rotational work to maintain cohesion and performance. These lessons are directly applicable to future analog astronaut missions, as well as future lunar or deep space missions. Looking ahead, the next steps include longer isolation studies, more integrated life support and crew interaction trials, and continued training of young astronauts, the youth, to prepare them for the challenges of space exploration. Special thanks to the Analog Astronaut Training Center, which made this mission possible, and of course the Kratos crew, whose teamwork over capacity conditions made this research valuable. Thank you for your attention.